Hi, welcome back to part 2 of the Marconi TF2500. So we've done a bit more disassembly. This is the what they call the amplifier board. And this is the board that's inside that metal can. It's a right pain in the arse to remove. You have to first of all take the knob off, and there are I think 4 or 5 screws holding it, the whole thing down into the chassis. Then there are, I think, 7 or 8 wires that are hard soldered onto the board. They will have to be taken off. And then finally you can get the can out and then detach the board from the can with, I think there are 8 screws. So, you know, this thing's in there. Was never designed really to be easily brought out. But I suppose it's part of the ethos of the machine that, you know, it's battery powered, it's portable. They wanted things to be very stable. And that even goes to some of these capacitors, which are tie wrapped to these sort of monolithic standoffs onto the board. You know, they really didn't want things moving about as this instrument was moved around from place to place. Anyway, we've managed to get it out. I've had a quick look over it. I've done some checking of resistors. The ones I generally am most worried about are these sort of older carbon composite ones. They have a tendency to drift certainly with age sometimes, but also with high use. I don't think this has had a lot of use looking at it. You know, there's no areas of heat, or, you know, none of the solder joints look particularly dry. So it might be quite a light use unit. Having said that, I am going to do a bit of preventative maintenance on this. So there's actually 1, 2, 3, 4, 5, 6 electricity capacitors, and mainly because of the age of the unit, but also because it's such a pain in the arse to get this out. I think I am going to just bolt replace all of those capacitors. It just makes sense. The poly ones, they are usually pretty good, so they'll be staying. There's 4 or 5 of those. There's quite a few polystyrenes. Again, I'm just going to leave those in for now. If we find problems later on, then we might have to come back and do some troubleshooting. But I think other than that, that's the only bit of preventative stuff I'm going to do. I'll do some checks on the diodes and things like that are on the board. But overall, not too bad. So I've got a bunch of replacements, which I happen to have on hand, near enough values anyway. So I'll get on with that, and then I'll bring you back when I've finished that, and we can just have a look at the finished board before I put it back in. Okay, so the capacitor replacement is done, and as you can see, the amplifier board is back in the unit. So I replaced, I think it was 5 or 6. So 1, 2, 3, 4, 5, 6. I took out these standoffs that they were using, really just for ease of replacement, or except one of them, which is this one over here, because it actually uses one of the standoff posts tied to ground for another poly cap. So I just elected to keep that one up there. As I say, I'm not really worried about the stability of the capacitors, because I'm not going to be moving this unit around and, you know, vibrating it. So you know, they're all in there solidly. So let's hope that it all works okay in the long run. So having done that, I did switch the unit on, and I put some signal into it just to see what was going to happen, and I didn't get anything, which was a bit of a concern. So I started on the schematics, and I started to trace the signal through, and the signal comes into the unit through the front jacks, and then it goes to a wafer switch on the front, which is the power and function selector, and from there it's routed up to whichever board is going to be in use, so the amplifier board for the voltage unit, or the resistance boards, and the back resistance plane for power measurements. And what I found was that the way this is wired up, from the selector switches, they use these shielded cables that are a bit like normal coaxial, but not. And they have an outer sheath. In fact, they have two sheaths with a shield in between them, which is then tied into ground. And then down the middle of this cable, there is the tiniest piece of copper wire, and one of those was broken. In fact, this is the one that was broken. I removed it from its shield. That's luckily I happen to have some of this stuff here, which is 0.3mm copper. It's actually coated, so I just cut myself a piece of that, burnt the coating off at both ends, and it's actually a very good match. So I was able to thread that down through the shield, and you can see that actually, in terms of conductivity and size, it's an excellent match. So anyway, I've redone that now, and I've done a few tests, and what I'll do now is bring you around to the front of the machine, and we'll have a look and see how we're getting on. Okay, so here we are at the front of the machine. Now I'm just powering at the moment from my bench power supply, so I've got that connected up to 18 volts DC, and we'll just turn her on, and you can see that in the first position, which is the battery check, yep, we're pretty much up at 18 volts, so all good there. Now I'm only interested in volts at the moment, so off camera to the left I've got an audio frequency oscillator. In fact, it's another Marconi. It's a TF2500, so good, trusty audio oscillator. I've got a couple of these. They're very good, very stable, sine wave only. And that's coming directly into the volts on the front. So when we're in volts, none of this impedance makes any difference. This is just purely now to be measuring the volts on the system. So I'll switch it into volts, and we'll bring the oscillator up to, let's call it, so this is 1 volt peak to peak. It's already up at 150 volts, so we wouldn't expect to see anything there, so I'll bring it down now to the 1.5 volt line, and you can see we do have a little bit of deflection, but not where I would have thought it would have been, which would have been on the 1.5 volt scale about here. We're using these two scales here. So let's just drop it another one, and you can see we do have deflection, which appears to be linear. Let's take it down another one. So this is now in the 0.15 volt, and we'll take it down one more, and it goes off the scale, so let's leave it there. And I'll just trim the audio frequency so it comes up to the 1 mark on this. So I'm just increasing the voltage. And that is a VRMS of 440 volts. Yeah. I beg your pardon, millivolts, obviously. So I'm not really sure what this is showing us. As I say, it's linear, so if I drop it, when I go into top scale, it's now showing 1, 10, so it's moving correctly, but whether or not we are not getting the drive to the meter, or there is a problem with the attenuation on the amplifier board, I don't know, or whether this is not actually meant to be showing us pure voltage, or whether it is, for example, voltage average is about 12 millivolts at the moment. So, you know, we're a little bit off, but again, that could be just a trimming issue. So the manual isn't very specific in this. I'm going to need to do a bit of research. But if I can't find anything as to what this is actually meant to be displaying, then I think the next step will be we'll have the amplifier board back out and I'll start to go through all the silicon in it. I've done some quick measurements and the signal's present all the way through the chain, but it doesn't seem to be amplifying from the pre-amplifier all the way through to the final drive amplifier. So we might have a problem with one or more of the transistors on that board. So that's the next step, but at least we do actually have the ability to get signal into the machine and it is measuring something. So that's a good bit of progress. That's all I've got time to do at the moment. So next step I think will be to do some more measuring on the amplifier board. Probably take the amplifier board out and start going through all of those transistors that are in there, see if we can see any issues with those or associated resistors. Okay, I think that's enough for part 2. Thanks for watching, and I'll bring you back when I've got more to report.